All right, so we're starting today, number 11, right? John, what's the problem?
It's like wrapping in a ball or something,
That was elimination problem.
or elimination, yeah.
Well, give me the two equations.
3x minus 3y equals 9. X plus 3y
Thanks. Equals what?
equals 7.
Thanks. All right, so elimination. When we do elimination, we want to eliminate one of the variables. Okay, so you want to write it like this, where everything's lined up. All your x's, all your y's, your equal to sign, and then the constants on the other side. All right, what you're looking for is which variable has the same coefficient. Okay, in this problem, it's already been taken care of for you, right? Some problems, none of them are the same, so you got to make them the same. Okay? So if you have to make them the same, you have to multiply one or both equations by some numbers to make them the same. Okay? Like if we wanted to change this and make the x's the same, I could just multiply the bottom by 3 and then they'd have the same number, right? You could do that if you want, but that's just doing an extra step in this case because we already got 3's same number in front of the y. Okay? The other thing is on elimination, when the signs are the same, you're supposed to subtract the two equations. If the signs are different, you're supposed to add the two. If you want to add that to your little note card that you're allowed to have, you can. Okay? Remember, the first 19 of these is what type of problem? Multiple choice. So, if you don't remember how to do elimination, you've got 4 choices. How could you figure out which one's the right one? No, you don't guess. Come on, you would know exactly what's right. What would you do? Just plug it in, right? Plug in your choices until you find the one that works. Does that make sense? So, Trent, no phone. Oh, okay. Thanks. All right, so the y's are going to get eliminated and the signs are different. So when they're different, I told you, you should add them, right? Because opposites, when you add, give you 0, right? So I got a 3x plus 1x, that's 4x. Negative 3y plus 3y, eliminate each other. And then 9 plus 7 is 16. Divide both sides by 4, and you know what your x is. Are we finished? No. You got to substitute in. Does it matter which one you sub in? No. I'm going to do the bottom. All right, so I'm going to substitute in that one. So I'm going to put a 4 in place of the x, plus 3y equals 7, and then solve for y. So you get 3y equals 3, divided by 3, you get y is 1. So 4, 1 would be the choice, A, B, C, or D that you'd want to put. Right, Coli? Okay? So again, even though I'm telling you to use a certain method, I'm just looking for the right letter. Okay? For the multiple choice ones. So you're not getting any partial credit for the first 19. Okay, which you'll do Friday, actually. You'll do 20 to 30 on Thursday, the ones you have to write out, and you'll get partial credit on. All right, number 12. We have to graph a system of inequalities. So this is where you graph two inequalities on the same XY axis and see where the two shaded areas overlap. Okay, so we're just going to graph these two. Again, this is going to be a multiple choice one, so pay attention to the shading in that. All right, so the green one, my y-intercept is 2, And my slope is -3, so I just put it over 1, so I have a rise and a run. So I'm gonna go down 3, 1, 2, 3, and over 1. Solid or dashed line? Dashed, right? All right, there's 0, 0. I'm gonna just check it, make sure it works, or see if it works. -3 times 0 plus 2 is 0 is less than 2. True or false? True. So I'm gonna go that way, right? Towards the 0, 0, because it was true. The red one, I started -1 for the y-intercept. The slope is 4. So I got 1, 2, 3, 4, and over 1. Solid or dash? Solid. Okay, so pay attention to that. Okay. I'm going to check 0, 0 again. Is 0 greater or equal to -1? Yes, so I'm going to go this way, right, towards the 0, 0. Where the two overlap is there, right? That area. So make sure you make the correct choice when you are finished. Number 13. First of all, can I add those two matrices? Yeah, they got to be the exact same dimensions. What are the dimensions of those two? 2 rows, yes, 3 columns, right? 2 by 3. So all you have to do is add the ones that are in the same spots. So I'm adding 4 plus 6 to that spot. I'm adding -7 plus 2 to that spot. And I'm adding 4 plus 1 for that one. And then 8 plus a -9. And 7 plus 4. And -4 plus 0. Any questions? That's pretty easy, right? I wouldn't waste time putting it in the calculator. Okay, you can if you want, but you don't need to. Now, 14 is another way to solve a system of equations. And it was using matrices. So you write it like you're doing elimination, line everything up. Okay, so what we did is we took the coefficients of the x's and the y's and made our A matrix, which is 2 rows, 2 columns. So it looks like this. And then we made a B matrix. That's 2 rows, 1 column. Oops, I don't need that. So we put that in our calculator. And then we had to do this to solve it in our calculator. Matrix A inverse matrix B. Whatever that equals gives us our answer. The top one will be X, the bottom one will be Y. Okay, so when we did stuff in our calculator for matrix, it's second matrix. And again, this is a multiple choice problem, right? So you're going to have 4 pairs of numbers you could just plug in, right? If you forget how to put it in your calculator. All right, so got to edit A. It's already 2 by 2, so I'm just going to hit enter. And then I'm going to put them in. -3, enter. -4, enter. 9, enter. 10, enter. Okay, then we have to get out of there, so we hit second mode for quit, second quit. And then go back in, second matrix, edit, number 2 for the B matrix. 2 by 1 is already there. And 9 and -3. Get out of there, second quit, and go back in. Just hit enter, and A will pop up. Hit the inverse button, which is the one you've been hitting, but don't hit second. So that -1 shows up. then hit second, that same button, 2 for B. You get 13 and negative 12. That's your answer. Again, for those of you that still, for some reason, don't have your graphing calculator, you really don't need it. Because you can just plug in the choices and figure out which one works, right? Questions? All right. Yes, Trent. The next group that we're doing is we just had a test over, right? It should be fresh in your mind.
Especially there.
Well,
Fond memories there. Especially when you don't have to.
well,
How to get out of that? Oh, there's exit. I didn't do that. Yeah, let's finish up and then I'll try to work on it. I'm not sure, I tried to do exit, it's not working. All right, so for 15, this is parabola stuff. We have a function, a quadratic function, because it's x squared, quadratic trinomial, right? Stuff we were talking about in chapter 6. All right, does this open up or down? Up, why? Positive 1 there, right? So do we have a min or a max we're looking for? Min. Okay. What we did to find the min is we found the vertex. So to find the vertex, I got to find the axis of symmetry first. So we use this little formula. So you might want to write this on your note card. It's been pretty fresh, though. You might still remember. All right. So negative b over 2 times a, which is a positive 2 over 2, which would be 1, right? So that gets me the x value of my vertex then. That x value, 1, is the x value of the vertex. So then I just plug 1 in to find my minimum value. So 1 squared is 1, minus 2 minus 6 is what, negative 7? So my minimum value is negative 7. Domain is always what for these parabolas that open up or down? All real numbers. My range is my y values. When it's a minimum, it's y is greater than or equal to, and it's whatever that minimum value is. Okay, so that's from chapter 5 stuff, which we just finished. Number 16, find the zeros of h of x. Another quadratic, it says by factor. So, is there a GCF for this? So, remember, when we solve these, we're supposed to set it equal to 0, right? So, is there a GCF for this, what I'm trying to factor? No. Is it a difference of squares? No. Is it a sum or difference of cubes? Is it one of those special trinomials? Is that a positive perfect square there? No, that is, but that one isn't, right? So it's just a regular trinomial. A is 1, so there's only one way to get x squared, x times x. So we're looking at factors of 60. All right, so you got 1 and 60. 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. That's about it, right? Do any of those add up to 23? Yeah, the 3 and the 20, right?
Yeah.
Or plus 3, plus 20. When the C is positive, they're both whatever the B is. So once we get there, we set them equal to 0 to finish up. So one answer is negative 20. And here again, you could plug in to the original. You got choices. You could plug in to the original, see if you get 0, right? You might be able to put that in your calculator and graph it and see if where it crosses the x-axis. You probably won't be able to see the negative 20 then. Okay? So there's a couple ways to do that. But if you're good at factoring, which you should be by now, you can do that. Here's another one by factoring. Same type of problems. Okay? They call them zeros when it's written in function form like 16. They call them roots when it's written in equation form like 7. So it's the same type of problem. Okay, since it says I'm supposed to factor, and again, this is another multiple choice. You could just take your choices and plug in and see which ones work, right? Which ones give you those two equal. So anyway, I want it equal to 0, and I like my A to be positive. So I'm taking the 30x and the 45 from the left side and putting it on the right side. So over here's the 0. Instead, normally we put it over there. And my 5x squared minus 30x plus 45. Is there GCF when I'm factoring for this one? Yeah, 5. So pull the 5 out. Get x squared minus 6x plus 9. And that's one of those special trinomials. What's the square root of x squared? X. What's the square root of 9? 3. Multiply those. Is that half the middle? 3x half of 6x? Yeah, so it's one of those special ones. But again, if you don't see that, it's okay to do this. Factors of 9, 3 times 3, add up to 6, negatives. Right? Negative 3 times negative 3 is positive 9. So since they're the same factor, can you say 5 equals 0? No. So all I'm going to say is x minus 3 equals 0. When you add 3, you get x is 3. There's only one answer. If you wanted to, you could put in your calculator and see that it bounces off at 3. Watch. 5x squared minus 30x plus 45. It bounced off right at 3. So if you want to do it that way, good. Questions? Okay, 18. Easy problem. Should be fresh in your mind. Going backwards, they're giving you the zeros. 6 and negative 8. The way we do this is we start with our factors. Always start x minus. And we just put those numbers. Put a 6 in and a negative 8. Well, what's x minus a negative 8? Plus, right? Just FOIL and you're done. So first, x times x. Outside, x times 8. Inside, negative 6 times x. Last, negative 6 times 8. Combine like terms. That's what I'm looking for. The function or equation that goes with those two zeros. 19. Supposed to solve this. Again, it doesn't tell you how to solve it. If you want to set it equal to 0 and graph it, you could. I don't know if you see it or not. But I see that this is one of those special trinomials on the left. These are both positive perfect squares. Square root of that's x. Square 25 is 5. When I multiply them, I get 5x. That's half of 10. Right? So this factors into x minus 5 squared. So how do I get rid of that squared? Square root both sides, right? Right, Trent?
Yeah.
Coli, you with me? I don't think you are. Well, can I pull out? 3. So what do you got to remember at this point? Plus or minus. Yeah, a lot of you forgot that when we did this. And then take the 5 over. So we're going to add it. So there's my 2 answers. Okay, questions? This should be pretty familiar. Wasn't that long ago, right? Okay, last one for today is solving this by completing the square. Okay? Okay, so when we complete the square, we want the A part and the B part on the left and the C part on the right. So the 3 was already over there, so I left it. I brought the 2x over by adding it. And then I have to add my blanks. I have to make it one of those special trinomials like we just did here. I got to make it into one of these so I can do this from here down. Okay? So, again, you might want to put this, put completing the square. You might want to put this little, the blank's always plus, and then it's b divided by 2 squared. So b is 2 in this problem, divided by 2 is 1, and when I square 1, I get 1. Okay, so then I'm going to factor it like that. You just take the square root of x squared, the square root of the 1, the blank that you put in there, and then whatever is in front, this sign here, goes between them. That's where somebody made a mistake on the test. For some of them, one of the forms it was minus there, and a lot of you put plus. Okay, so just pay attention. 3 plus 1 is 4. Now it's just like the last one we did. Square root both sides. So I get x plus 1. Square root of something squared is itself. Plus or minus 2. And then subtract the 1. There's 2 problems here, -1 plus 2 and -1 minus 2. -1 plus 2 is 1, and -1 minus 2 is -3. Okay, that would be the first one that you actually have to show all your work. That type of problem will be your first problem on the exam Thursday. Any questions? Again, if you're paying attention and writing down stuff on your note card as we go, after tomorrow class, you should be ready. You don't have to do much outside of class. Tonight's assignment is what? The rest of it, right? 21 to 30. Okay? And we'll do the same thing. I'll go over it with you. And like I said, if you've been paying attention yesterday and today through this and have tried to do this ahead of time, you should be ready to go. So I'm trying to make it so you don't have a lot of outside stuff to prepare because I know you got other classes. You good? Look good, feel good?
You are good.
You are good. Yes, you are.